Welcome to This Explainer. Today, we're unpacking something that honestly feels a bit like a digital magic trick. We're talking about virtualization technology. If you've ever found yourself wondering about the actual mechanics behind the grand illusion of the modern data center, well, you are definitely in the right place. So think about the physical limitations of traditional IT. For the longest time, the rule was pretty simple, right? You had one physical server, one operating system, and one primary application. But what happens when that application only uses, say, 10% of the computer's actual power? Well, you end up with a room literally full of expensive, power-hungry machines doing a whole lot of nothing. It's wildly inefficient. So it begs the absolutely critical question: how do we make one physical computer act like 10 or even 100? To solve this, computer science turned to a truly brilliant illusionist solution. Okay, let's dive into this. At its absolute core, virtualization is the process of converting a physical IT resource into a virtual, rather than actual version of something. It's basically the art of separating the software we use from the physical hardware it runs on. Here is our roadmap for today. We're going to cover what is virtualization, meet the hypervisor, why go virtual, types of virtualization, the cloud connection, and finally, real-world considerations. Okay, moving right into part one. What is virtualization, the art of the virtual? Our source material uses a really great analogy to ground this abstract concept into reality. Think about carpooling. If you and 5 of your neighbors each own a car, but you only drive them for about 2 hours a day, those vehicles are spending the vast majority of their time just sitting there idle. Virtualization is exactly the equivalent of pooling those resources and sharing a single vehicle to maximize its efficiency, ensuring it's constantly in use. Let's look at part two. Meet the hypervisor, the master illusionist. And this brilliantly illustrates how the magic actually happens. The hypervisor, which is also known as a virtual machine manager, is this specialized piece of software sitting directly between the physical hardware and the operating system. It acts as the ultimate traffic cop. It takes decoupled applications and assigns exactly how much access each operating system gets to the processor, the memory, and disk inputs and outputs. It can chop up one machine into several virtual machines, or even pool multiple physical resources into one single virtual pool. Moving on to part three. Why go virtual? Escaping the physical box. The benefits outlined in the source are massive. First off, you save money. You're turning a single-purpose server into a flexible, multitasking powerhouse. Second, you save energy. Having fewer physical servers means a massive reduction in power and cooling costs. Third, you save a ton of time because there's far less manual maintenance involved. And finally, you reduce desktop headaches. Centralized management completely eliminates the absolute nightmare of running around trying to fix individual physical machines. Now for part four, types of virtualization, the repertoire of tricks. Once you successfully decouple software from hardware, you can start chopping up different layers of the IT infrastructure. It's kind of like a giant puzzle. You can partition one physical server into several independent virtual servers. You can use network virtualization to split your available bandwidth into independent secure channels. Or you can use application virtualization. This lets you containerize an app, separating it from the OS so you can instantly relocate it without disrupting any other systems. It's pretty amazing. Moving a bit further down the stack, desktop virtualization lets a centralized server deliver remote, highly individualized workspaces right to the users. For deeper emulation, hardware virtualization actually creates virtual machines that entirely mimic physical computers, whether that's fully, partially, or via paravirtualization. Developers can even leverage service virtualization to emulate entire dependent system components for risk-free testing. Finally, we can virtualize the foundational data layers themselves. This means you can aggregate RAM into a single pool for memory virtualization or abstract logical storage entirely away from your physical drives. This even extends to decoupling the database layer, presenting data as this abstract layer totally independent of the physical structures below it. As you can see, it's an incredibly comprehensive list of ways to just shatter physical limits and unleash digital potential. Let's hit part five, the cloud connection, the grand stage. Our source material has this great aha moment that perfectly sums up the relationship here. It says, virtualization increases the efficiency of hardware utilization, while cloud adds a layer of management so that virtual machines can be created, scaled, and torn down as required. Simply put, virtualization makes sharing possible, but the cloud makes sharing mandatory. Relying on virtualization infrastructure management, or VEM tools, is literally the reason the vast majority of today's cloud solutions can even exist. Finally, Part 6. Real-world considerations. Behind the magic. So the crucial point to remember here is that virtualization does introduce overhead. For really complex systems that don't actually need resource sharing, this overhead causes a performance drag. You often have to step in with para-virtualization APIs just to fix it. There's also hardware compatibility to think about. Specialized hardware might just lack the right device drivers, which forces you to use commodity hardware instead. And lastly, portability gaps between different vendors can be a real headache. Though thankfully, initiatives like the Open Virtualization Format, or OVF, are stepping up to standardize virtual disk images. Virtualization absolutely breaks the chains of physical hardware. It lets us pool, share, and scale our resources in ways we used to only dream of. It really is the invisible engine powering the modern cloud. But I want to leave you with this final thought. As we rely almost entirely on the software illusion of these virtual environments, what's the ultimate future of our physical hardware? Is it destined to just become a silent, invisible commodity humming away in the background of our digital lives? Think about it. Thanks so much for joining me on this explainer, and keep learning.